You didn't start ready.
Yes. Okay. So we discuss strings, right? And we
Yeah.
saw that string we can combine multiple characters, but still those are same values. The first collection that generally we study and we talk about and we use more often, okay, more often than even say set is called your list, okay, and this is a linear collection. Linear collection means obviously it's the one dimension and linear ordered collection. Ordered because each element has a position number. So order is automatically assigned to it. And also we say mutable. That means you can edit the value. Your strings were immutable. Okay. Your strings were immutable. Even your sets are mutable. List is mutable. Dictionary is mutable. Your tuple, which we'll see next, is immutable. Your strings are immutable. You have something called as Trojan set. Trojan set is a immutable version of set, okay, which is immutable. Means you cannot edit the value once you declare it. But in list and sets and dictionaries, you can edit the values. So let's see. If I have to declare
Mm.
an empty list, you use
Uh, in list, dictionary, and such, we can edit it. In what we
yes.
can't edit it?
Strings we can't edit, tuple we can't edit.
Okay.
Yeah. So this is how you declare an empty list. Okay. Square bracket is used to declare an empty list. Okay. So
Mm.
so when you print list one here, okay, and when you run it, okay, oops, it's still pointing to the wrong file. I'll change it to P1. Okay. So you get blank. So this is second use of square bracket. We have used square bracket before. You remember for what we did?
Mm, I think I don't exactly remember for what we used,
Indexing.
but okay.
Indexing, right? When we wanted first element from the string, third element from the string, right? So for
Mm.
indexing we used, and we will use indexing here also.
Okay.
So square bracket is used for indexing, no matter which collection you use. String we used, list also we will use, dictionary also we will use. Later we'll talk about pandas, numpy. There also we will use the square bracket for indexing.
Okay.
So now you can define some values. Okay, if you want to see the type, you can say print type of list one. Obviously, you will get this class list. Okay, now you can
Mm.
add some values to it. Okay, list can take integer, can take float, can take your string, can take your boolean. It can even take a it can even take a list, right?
Okay.
So list can take any data type. Okay.
Mm.
Okay. Now, if I ask you how many elements are there in this list, how many elements do you think are in the list now here?
7.
Okay. So we can directly say number of elements equal to, okay, text, and then I'm using len. Len is a function which will tell us number of elements. Now, when you do it, you get 6. So 1, 2, 3,
Oh,
4, 5, 6.
sorry.
Yeah.
Oh, yeah. I also counted 6 and 5 separately.
Right.
Sorry.
Dot. Yeah. So dot.
Yeah.
Yeah. Generally, you get confused with comma. Okay.
Yeah.
Yes. So you have 6 elements here,
Mm.
right?
Okay.
Okay. Um. So now, if you have to do the indexing, Okay, so remember indexing starts with 0 in Python. So the first element is going to be your 0th element. And so we have two types of indexing we discussed right before. Your positive indexing, which starts from 0, 0, 1, 2, 3, 4, so on. And then negative indexing, which starts from backward, -1, -2, -3. Okay. So let's say
Mm.
if I want the second element from the list, so I'll say list 1 of 1. List 1 of 1 will give you 4,
Mm.
right?
Yeah.
Then, okay. And then you can also say print list 1 of -2. -2, this is -1. -2 should give us true. So when you run it, you get true. Okay. Now refer the same note. Okay. So indexing is exactly same like string indexing. Now, if I do print list 1 of -1, you get 2A12. Oops. Now, this entire thing, now see, the type of list 1 is list. But if I do type of list 1 of -1, this will also be list, right? Now, if I do
Mm.
type of list 1 of -2, it's going to be Boolean here, right?
Okay.
So, see, when you put them together in a list, together they behave like a list, but they are individually they retain their own property. They are integer, they are float, they are boolean, they are list. Individually they retain their property, but together they represent a list.
Okay.
Make sense?
Yeah.
Okay. Now we'll talk about, okay, some inbuilt functions.
Mm.
Okay, there are inbuilt functions. Of course, it has good number of inbuilt functions, but not as many as string. String had too many. Okay, so first thing is, how do I add a list? Sorry, how do I add a value to a list? Okay, how do you add value to a list? Right? So, let's say I want to store marks of 5 students,
Mhm.
right? So let's say question is, okay, so if you have to, let's say, okay, so you have to find sum and average of 5 marks. Okay, so earlier when we didn't know loop, what we did was we did a m1 equal to input, m2 equal to input, so on, sum m1 plus m2 plus m5, so on, right? We calculate average and sum. When we did loop, what we did, we said for I in range 5, okay, and we
Mm.
said m equal to int of input, enter marks, right? And then since loop will keep on replacing the value, so what we did, we said sum equal to 0 and we added value m to sum here. This is what we
Mm.
did, right? And then we say print sum equal to sum. But problem in this case was you will lose the value, right? So enter the marks. 4, 4, 4, 4, 4. Okay, 20. But you lose the 4, 4, 4. If you want to see the values, you won't be able to see the values. Right? So in this case, what I'll do is I will declare an empty list also. I'll say list of marks equal to blank list. Now, before you run the loop, I will say list of marks dot append. Append is a function to append the marks here. So I'll say list of marks dot append m. Okay. Now outside, if you want to print the list of marks, you can say list of marks equal to list of marks. Now when you run it, now I say 5, 4, 9, 1, 2. 5, 4, 9, 1, 2. You see that? So now you're able to store the values. So you can append the value. When you say append, that means you're adding at the end. So there are two ways to add values. Okay. Now what I'll do, just to avoid running this again and again, I'm going to say 0. So there are two ways to add values. To an existing list. Okay. One, you have append, and second is insert. Now, if I say list of marks dot insert, so it takes index and object. Okay. So we have to first give index. Okay. It takes index comma value. Now I want to add, let's say 100. Okay. But which position you want to add 100? I want to add 100 at first position. So I'll say first position will be 0. Right? I want to add at, say, second position. I'll say 2.
1. It's not 1.
Okay. You want to add at, okay, index is one more, one less than the position, right? So if I want to add second position, then I will say 1.
Yeah.
Right? I want to add at second position. So I'll say index is 1. And initially it is, of course, empty. List is empty because we are not adding, right? Now, let's say 100, 80, 90, 30, 40. Okay. Now see what happens. So I said 0 here. That means this part will not be called, right? So list of marks will be empty here. The list of marks is empty. You are saying insert 1 comma 100. So you have list, into that you are inserting 100 at, I'm saying, second position. But this empty list does not have second position. So by default, second position is first position only. Correct? So it'll get added at first position. Now I'm saying add 80 at second position. So 100 it has first position, 80 will get added at second position. Fine. Now again I'm saying add 90 at second position, but 80 is at second position. So 80 will be moved to the right and 90 will get added at second position. You see that? So you have 100, 90 and 80 now. Now again third I'm saying as second position. So 90 is a third. So 90 will go to fourth. Okay. So everything will shift towards right. Okay. If you want, you can actually put after every insert and see the difference. Okay. Empty. Now you're adding 100. So 100 I'm adding second position, but there's nothing, there's no first position, right? So if there's no first value, how can I add second position? So you'll add at the first position itself. So here second doesn't mean anything. Now I'm saying add 80 at second position. So yes, 80 will get added at second position. Now I'm saying add 90 at second position. So 90 is getting added at second position and 80 will shift to the right. Now 30 gets added and everything else shifts to the right. You see that?
Okay. Yeah.
Okay. So this is how the insert will happen.
Okay. When you are printing this print list of marks, are you just using Control C and Control V, or are you using any other keys?
I'm sorry. When you are?
Right now you just pasted these print line, right?
Uh-huh.
So when you're using that, are you using just Control C and Control V,
Yes, yes.
or okay?
Okay. So if Windows, it works that way, right? If you're
Yeah.
using Mac, then it's different, right? But yes, Windows, it's
Okay.
Control C, Control V. Yeah.
No, I just wanted to know if you're using any other key. So just I
No,
was asking that.
no. So yeah, Control C, Control V works. Okay.
Yeah.
Perfect. Okay. So this is how you can add values to this. Now, how do I remove the value from the list? So list of marks dot. As always, dot will give you the list of all the available methods that you have. We just did insert and update. Sort. Sort will sort the list of values. Okay. So let's say if I say sort here, and then I will go here and I'd say sort, right? So by default, everything is sorted in increasing order. See, you can directly sort in increasing order. If you want to sort in decreasing order, you say reverse equal to true. And when you say reverse equal to true, so it got added in reverse format.
Mm, okay.
Okay. You can do reverse as well. So reverse will simply reverse it. Okay. So I'm going to say list of marks dot reverse. So it again reverse. So reverse is nothing to do with sort. Okay. Whatever you give, it will simply reverse it. So if we had given before sort, it would have reversed. So first element becomes last, last becomes first, second becomes second last becomes second, right? Just the reverse. Okay.
Yeah.
So this is your reverse. Then what else we have? Reverse, sort, insert, append, clear. Clear, just like in sets also we saw. Clear will remove all the elements. Okay. Whatever elements you have, it will. So the variable is not deleted. Variable remains. Just the content of the variables are removed. It becomes blank, totally blank list.
Mm-hmm.
Remove and pop. So see, remove and pop, there are two functions to delete values. Remove takes object to delete. So remove will ask you which element do you want to remove. So here I have 90. So I'll say, okay, I want to delete 90. 90 will be removed. Pop will take your index. Pop will say which index element you want to remove. Okay. So, so I say remove. Let's say we do 80. Now, when you print the list, okay, 80 will be gone. Now, if I say 800, and now when I run it, so you get exit code 1 error. Okay, X not in the list. So before you actually check, okay, to remove an
Mm.
element, check if that element is in the list or not.
Okay.
If it is not there, then don't remove it because it will throw error, isn't it? Error means your program will end, right? So you don't want your program to end abruptly.
Mm.
Okay. How do you check? Using in. So something like this. Num to delete equal to, let's say, 800. You say if num to delete in list of marks, right? If num to delete in list, only then you remove num to delete. Otherwise, do not. So now if you run it, you don't get error. Okay.
Mm.
But nothing gets deleted, obviously, because 800 is not there. If I give 80, 80 is gone.
Okay.
Then you have something called as list of marks dot pop. And index you give. Index can be 3. 3 means which element should we get removed? 100 will get removed.
100. Yeah.
Yes. So you can display it. I'm going to say pop list of marks. 100 is removed. Okay. What else we have here? Pop, remove, reverse, sort, insert, append, clear, copy, index. Okay. Index and count and extend. These are the 3 things. Index. Okay. First, let's start with count. Count will tell you how many elements are there. Okay. So one way to delete is you check if it is in the list or not, or you can also see the count. That means, let's say num to delete. Okay. Num to delete equal to 80. Now, here what I'll do is, if list of marks dot count num to delete has to be greater than 0, it will find number of count of those elements. If it is greater than 0, then only you perform remove. Otherwise, don't perform remove. Right? So that's what I'm saying. Count should be greater than 0. If count is greater than 0, then you remove it. So count will count how many such elements are in the list. How many such elements are in the list. Okay.
Mm.
Then you have um, what was it? Index. Yes. So index will tell you the position. Okay. So now if I declare a list 1 equal to 3, comma 4, comma 5, comma 3, comma 4, comma 6, comma 3, comma 7, comma 8, comma 3, comma 6. Now count list 1 dot count of 3 will give us the count of 3, isn't it? So
Mm.
4. Now if I do index here, print list 1 dot index of 3. What is the index of 3? 0. So
Mm.
even though you have 4 3s in the list, but index will always be given for the first element. Okay. Now if I give 10 here, now the index will become 1. Right? Now I want to print index of the entire um, all the values of 3. So to do that, I have to iterate through the list. How many threes are there? I know there are there are 4 threes. So
Mm.
I need to figure out 4 trees and get their index. Okay. But every time
Yeah.
I do index, it will give you the first index. So there's an option here. Index has two other values. Of course, your element, and then you can say start and end. You can say that, no, don't. So here, if I say instead of after 3, 1 is there, right? If I say 2, if I say 2, then it will look for the appearance of 3 after position 2, after position 1 from 2. So this is 0 and this is 1, right? This is 0 and this is 1. These two are ignored. After
Mm.
this, when is the next 3? So 2, 3, and 4. That's why you're getting 4. If I do 1, you get 1 only. Because 3 is at first position itself. So 3 is done. So if I give 2, it will give you the next value. So next value is at 4. So I'll give 5 now. If I give 5, it'll give me the position of the next one, which is at 7. Now I give 8 here.
Mm.
Okay, 10. 10 is done. That's the last 3. So if I give 11, okay, it will say exit code 1. Okay. So to do the index, the value has to be there. To delete, value has to be
Mm.
there. To do index also, value has to be there. Otherwise, you end up getting error. So
Okay.
if I have to do this, okay, what I will do is index of all the values in the list. So I'll say i for I in range. Can you hear me?
Yeah.
Okay.
Okay.
So for I in range, and instead of giving 1, 2, 3, 4, I don't know, right? So I'll simply say count. Okay. So I'll say element to search. Okay. Let's equal to 3. So I will say 3 here. So that means if there are 4 trees, my loop will run 4 times. And to find the index, I'm going to say print index equal to your list 1 dot index, list 1 of this index element search. Okay.
Mm.
So this is going to give me element search. Okay. And I'm going to say print comma and equal to comma here, right? So now when I run it, you will get 3, 1, 1, 1, 1, 1 only because I'm searching from beginning. So here I have to give the number. Now, in the beginning, it has to be 0. But second time onwards, it has to change based on the previous value. So I will say index found or something like that. Initially, I'll make it 0. Okay. So I'll say index found equal to 0. Next time, what I will do is index found equal to, okay, okay. So index found equal to the previous value and it has to be plus 1. Because if you found at first position, next time I need to search from second position. If you found at fifth position, I need to search from sixth position. So now when you do it, you see 1, 4, 7, 10. All 4 indices are found.
Mm.
Okay. So these are properties of list.
Okay.
Makes sense?
Mm.
Okay. There is one other concept, tuple. Tuple is your immutable form of list. Okay, if you do not want list to be edited, that means you don't want list to get values, add values, remove values, update values. Okay, this is not
Mm.
going to work. Okay, before that, I need to talk about a couple of more features in list. So let's say I
Mm.
say list 1 equal to 1357. I say list 2 equal to list 1. Okay, and then I say list 3, okay, equal to list 1 dot copy. Okay, so I'm going to say 1 comma list 1 equal to list 1. Two, three, two, three. Okay. What happened?
Mm.
Why list 1? Okay. This is because here it's all end we have done, right? So it's printing in same line. So we'll just put a blank print so that it comes down to the next line. So list 1 is 1357, list 2 is also 1357, and list 3 is also 1357. Okay, so these are two ways to copy. If you want to copy, make a copy of list. Okay. If you want to copy, these are two ways to copy. Okay. But what is the difference
Mm.
between them? Now, let's say I add something to list 1. I add 15. And let's say list 2, I remove 5. And list 3 also, I need to do something. So let me add to list 3, 19. Okay. So I've made
Mm.
some changes to list 1, list 2, list 3. Now let's print and see what happens. Do you notice any difference?
Mm. Yeah, the change in the numbers.
Yeah. So see here, list 1, we said append 15. So list 1
Mm.
has 15 and list 2 also has 15. I did not say list 2 dot append 15, but list 2 also has 15. I said list 2 dot remove 5. So 5 is gone from list 2. 5 is
Mm.
gone from list 1 also,
Okay.
right? So what it
Yeah.
means is when you say equal to, they are same. Just has two names, but it creates a copy. So you say equal to, it's like giving say one person two name, right? So if I call you by your first name or call you by the second name, you're going to respond. Same thing is happening here. You append, so
Mm.
both getting. So it's not both, it's the same thing. Okay. So whether I say list 1 or I say list 2, it means the same.
Mm.
That's why
Yeah.
both are showing the this thing. And this is what will happen when it is mutable, right? You can edit the value of the list. Okay, there's something called an
Mm.
extend. Extend is like appending the same list. That's why we discussed update in set. Something like that is an extend. So you are adding list to itself. So when you say list 1 plus list 2, list 1 plus list 2 will give you a new list, third list. But list
Mm.
1 dot extend list 2 is like adding list 2 to list 1. So list 1 value will now have the new values, more values to itself. So that's extend. So with that, we finish our list. Those are the functions that are there. We'll do some programs later, we'll couple of programs we'll
Sure.
practice.
Yeah.
Uh, then comes tuple. Tuple, as I said, it's a immutable form of list. So if you want to create a tuple, you create using simple bracket. Okay, this is how you create a tuple. Square bracket for list, curly bracket for set, and simple bracket for tuple. Now, if you do here print type of T1, you do get tuple. Okay, but now if I say, if I want to add one element to it, so if I say one, okay, and run it, you get integer. You see that? Okay, because when you give one, right, it could mean that you are trying to give number using simple bracket, like BODMAS rule. In BODMAS, B stands for bracket, isn't it? So it thinks this bracket as that bracket, the BODMAS bracket. So see, when there's a confusion, you have to assume one thing by default. Okay, so it assumes that you're talking about BODMAS bracket. That's why it is showing as integer. Okay, so
Mm.
when you are handling one value in a tuple, just say comma. When you are handling one value in a tuple, just say comma. Okay, for 2 3 value doesn't matter, right? Because in integer, in BODMAS, you will not say 5 comma 6. You will say 5 plus 6, 5 plus 2, 5 into 2. You will not say 5 comma 2, right? So
Mm.
for more than one, it doesn't matter. But for one, you have to give comma. That's the extra thing that you have to remember.
Okay.
For three, for having two values, three values, five values, you don't have to give extra comma. Okay, so this is one thing that you need to remember. And now once you declare this, and when you say T1 dot, you see you only have index and count, no other
Mm.
methods,
Mm.
right? Index, if you give the value, it will tell you where in that tuple the value is present. Count will tell you how many elements are in the tuple, right? So because it is immutable, we do not have so many methods to talk about. But if you want to add some element, what do we do? You can convert tuple to list.
Okay.
Okay, list of T1. So now T1 is no longer tuple. T1 has become list. You see that when you say dot, you see append, remove, copy, index, all the functions of list are available.
Mm.
So you can convert a tuple to list. And again, you want to add, so you say T1 dot append, you add 50, 40, whatever, and convert it back into tuple.
Okay.
So you can convert tuple to list to tuple without any problem. So now you know that you can convert tuple to list to set to tuples. So all these three things, your list, tuple, and sets are all three interchangeable or convertible. Okay.
Okay.
If you want tuple like list, you say list of. You want list like behave like tuple, say tuple of. Advantage of tuple is it's fast. Accessing is fast.
Mm.
Advantage of tuple, and that's why tuple is used when you're doing for loop. Okay, when you are performing reading kind of operations, you will use tuple. Okay, when you're doing reading kind of operations, we prefer tuple, not list.
Mm.
Okay, you have something called as packing, unpacking in tuple. Couple of topics before we end.
Mm.
So let's say, see, so what we did, let's say I said T2 equal to 1, 2, 3. I'm assigning three values to tuple. Okay. Now, this is called packing. Okay. You're adding three values to tuple. I can say A comma B comma C equal to T2. This is called as unpacking. Okay. Adding
Okay.
more values to one. Like in suitcase, when you pack, you put a lot of things in one suitcase. Packing. And once you are done, you unpack. That means you remove things from your suitcase separately. So
Mm.
if I do A comma B comma C, you will get 1, 2, 3. Right? So this is what we call as packing and unpacking.
Okay.
So this is what list and tuple is. So we have seen list, tuple, and sets so far in collections. What is left is your dictionary. Dictionary doesn't have auto, it's unordered. Or dictionary is also unordered. It uses its own key to um, key to um, track values.
Mm.
Okay.